Welcome to another PyCrustable Math Shorts. In this video, we're given a perimeter fence length and we need to find the dimensions and the maximum area. We're going to use the derivative for these. It's not magic. First, we're going to look at the process. These are super easy when you follow the process. There are a bunch of steps, but trust me, you're going to like this. I'm going to give you a problem to practice. There'll be a self-quiz to try a problem without looking back at your notes. And finally, there's going to be a video task. I mean, you can't get good at math unless you practice. Let's look at the process. Once again, these are super easy when you follow the process, okay? But there's a lot of parts. The first part is you need to read the problem and draw a picture. A lot of students will read the problem but skip drawing the picture. Trust me, this is really going to help you. Number 2, label the sides or the fence of the picture. Number 3, we're going to be using these two formulas. Area equals length times width, and perimeter equals 2 sides plus 1 side. Number 4, substitute the amount of fence in for the perimeter. Number 5, solve for either letter in the perimeter. That means you want x equal or y equals. Number 6, substitute what you get into the area. Number 7, find the derivative. Number 8, solve for the variable in the derivative to find the first dimension. Number 9, use the perimeter to find the second dimension. And finally, number 10, substitute the dimensions into the area formula to find the max area. Now let's put this whole process together. A farmer wants to fence in a rectangular plot of ground adjacent to the barn to keep animals out of the garden. If she has 100 feet of fence available and wants to use it all, what dimensions will maximize the area? What is the maximum area? First thing I said you had to do is you have to draw a picture. And then you need to put variables in for what we're looking for. So this farmer wants to put a fence around her plot of garden. I used x and y. Now it doesn't matter. You can have 2 y's and an x, totally doesn't matter. Number 3, we're going to be using these two formulas. Area equals length times width, and perimeter equals 2 sides plus the 1 side. Number 4, substitute the amount of fence in for the perimeter. Number 5, solve for either letter in the perimeter. You could solve for the x or the y, it really doesn't matter. Number 6, substitute into the area. Number 7, find the derivative. Number 8, solve for the variable in the derivative to find the first dimension. And number 9, use the perimeter to find the second dimension. Finally, number 10, substitute the dimensions into the area formula to find the maximum area. Let's look at the process in action. A farmer wants to fence in a rectangular plot of ground adjacent to the barn to keep animals out of the garden. If she has 100 feet of fence available and wants to use it all, what dimensions will maximize the area? What is the maximum area? So the first thing we have to do is we need to draw our picture. The second thing we need to do is put in our variables. Now it doesn't matter if you have a y and an x. You could use m's and l's or whatever. Number 3, we're going to use these two formulas. Area equals x times y, and perimeter equals 2x plus y. Number 4, we're going to substitute the amount of fence in for the perimeter. She has 100 feet of fence, so I'm going to put 100 in for the actual word perimeter. Number 5, let's solve for a letter. Like I said, it doesn't matter which letter to solve for, but since y is kind of by itself, I decided to subtract 2x from both sides. So now we get 100 minus 2x equals y. Number 6, we're going to substitute into the area. Remember, the area is x times y. We found out that 100 minus 2x is y, so I'm going to put that in for y. I'm going to use the distributive formula, so x times 100 is 100x. X times negative 2x is negative 2x squared. Number 7, find the derivative. We end up with 100 minus 4x. Number 8, solve for the variable in the derivative. So we're going to make 0 equal to 100 minus 4x. I'm going to subtract 100 from both sides. Now you could add 4x to both sides. It doesn't matter because we're going to end up with the same answer. I have negative 100 equals negative 4x. I divide by negative 4, and I have 25 equals x. So I have my first dimension. Number 9, we use the perimeter formula to find the other side. So 100 equals 2x plus y. We just figured out that x is 25. Following my orders of operations, I have to take 2 times 25 first. I'm going to subtract 50 from both sides, and that gives me my second dimension, 50 equals y. The first question is, what dimensions will maximize the area? Well, 25 feet for x, 25 feet for x, and 50 feet for y. Number 10, what is the maximum area? What we're going to do now is we're going to substitute the dimensions we just found into the area formula to find the maximum area. Area equals x times y. X is 25, y is 50. So it turns out that the maximum area is 1,250 feet squared. Now that wasn't too bad, was it? No. A rectangular plot of recreation land is bounded on one side by a river. The owner has 500 meters of decorative fence for the other 3 sides. What are the optimal dimensions? What is the largest area that can be created? For this one, I would like you to pause the video, follow the process, and then press play to check. Now remember, if you get stuck, you can always press play to check. Let's see how you did. Number 1, we have to actually draw our picture. This is my little plot of recreation land, and they tell us that the land is bound on one side by a river. Let's put in some variables, all right? The area is x times y, and the perimeter is 2x plus y. Now we're going to substitute in 500 for the perimeter because that's how much fence this owner has. So 500 equals 2x plus y. I'm going to solve for a variable. Now I like to solve for y because it's 1y, it's by itself. I'm going to subtract 2x from both sides. So I have 500 minus 2x equals y. Great! Next, we're going to substitute into the area. So area equals x times y. We just found y, so I'm going to substitute that in for y. And then I'm going to use the distributive property. So x times 500 is 500x. X times negative 2x is negative 2x squared. We're going to find the derivative. So that gives us 500 minus 4y. We need to solve for the variable in the derivative. We're solving for x. We're going to subtract 500 from both sides. I have negative 500 equals negative 4x. I need to get x by itself. I divide by negative 4, and that gives us 125. Now that's x. That's one of the sides, but let's find the other side. Use the perimeter formula to find the other side. So 500 equals 2x plus y. We know that x is 125. 2 times 125 is 250. When I subtract 250, it turns out that y is 250. What are the optimal dimensions? Well, 125 by 125 by 250. What is the maximum area? Well, we're going to substitute the dimensions into the area formula to find the max area. Area equals x times y. 125 is x. 250 is y. When we multiply it, we end up with the area, the maximum area, of 31,250 meters squared. Now it's time for the self-quiz. You're going to pause the video, complete the questions, then press play to check your answers. The whole idea of the self-quiz is to complete the questions without looking back at your notes. A house owner plans to fence in their rectangular backyard using the side of the house as part of the fence. They already purchased 200 feet of fencing. What dimensions will give the maximum area, and what is the maximum area? Pause the video, complete it, and then press play to check. Let's see how you did. The first thing we did is we read it and we drew our picture. Oh, look at the dog. He's so happy. Now we have to label our variables. We're going to write down our two formulas. Area equals x times y. Perimeter equals 2x plus y. We're going to substitute in the perimeter. Well, we have 200 feet of fencing, so that goes in for the perimeter. Perimeter equals 2x plus y. I need to solve for a variable. The easiest variable to solve for is y. I subtract 2x from both sides, and that gives us 200 minus 2x equals y. Next, we need to substitute that into the area. Well, area equals x times y. We just solved for y, which is 200 minus 2x. I put that in. Now I have x times 200 minus 2x. We're going to use the distributive property, and we get 200x minus 2x squared. We're going to find the derivative. We end up with 200 minus 4x. We're going to solve for the variable in the derivative, which is x. I'm going to subtract 200 from both sides. Now I'm going to divide by -4, and this gives us 50. So that gives us one of the dimensions. We need to find the other dimension. We're going to use the perimeter to find the other side. The perimeter is 200 equals 2x plus y. X is 50. Following the orders of operations, 2 times 50 is 100. Subtract 100 from both sides, and it turns out that y equals 100. What will give the maximum area? 100 feet by 50 feet by 50 feet. What is the maximum area? Well, we're going to substitute the dimensions into the area of the formula to find the max area. Area equals x times y. X is 50, y is 100. This gives us an area of 50,000 feet squared. Awesome! All right, so what are your video tasks? What do you do next? Well, you need to practice, practice, practice. You need to practice, practice, practice. Did you like it? Well, like it. Did you really like it? Well, then subscribe. And finally, did it help you? Well, why don't you share it? Remember, it's not magic, it's math.